Hello everyone and welcome to my video here where we'll be factoring quadratics. This is a little bit of an intro, basics to factoring quadratics. We're going to start with a general idea of what that means and use a equals 1 quadratics. Alright, so let's take a look. Maybe you've never done this before and you're thinking to yourself, what does that even mean? What? I don't understand. Alright, so let's take a look at a couple things. First, a quadratic. Quadratic in standard form is y equals ax squared plus bx plus c. A quadratic is basically any polynomial where the largest exponent is a 2 on the x. All right, so that's what a quadratic is. That's the standard form. So when I say factor quadratics a equals 1, a being this number here, that means that the leading coefficient or the number in front of x squared is 1. All right, so that's an idea. Two, what does it even mean to factor a quadratic? Well, let's take a look at things that maybe you're comfortable with. 3 times 5 is 15, okay? All right, so let's say I said factor 15. What are the factors of 15? You could say, oh, well, 15 factors into 3 times 5. So maybe you're comfortable saying, oh, I can multiply 3 times 5 to get 15. Well, the opposite of that would be factoring it back to 3 times 5. So that's kind of what factor and quadratic is. Maybe you're comfortable with distributive multiplication, or sometimes people refer to this as foiling when you're multiplying two binomials. Right? You have two binomials, and you're like, oh, x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. And then you combine the middle terms because they're like terms, and you end up with this, okay? What we're going to do is we're going to factor. So instead of going from the top here, where we multiplied these two together to get the quadratic, we're going to go in the opposite direction. We're going to take the quadratic and go back to its factors. Okay, so let's take a look at how we do that. All right, so here we have 4 different quadratics. All right, they're all different. They look similar, but you can see the signs are different. All right, so again, this is going to be the basics. We'll do a little more complicated examples in the next video. So we just want to get an idea what the basics are. Here again, these are a equals 1, so that means that there's a 1 in front of the x squared, or we don't really see it because we don't write the 1, so it looks like there's nothing, but there's a 1 there. All right, what we want to do is we're going to factor this into two binomials. All right, so what I like to do is just set up those parentheses. I know that's going to be what I end up with, so let me get that there. Now, when you're factoring quadratics, the first thing you want to look for is a GCF. There is no GCF here, so I don't have to worry about that. And if you don't know what I'm talking about, there's 2 videos you could take a look at that happened before this. All right, so no GCF, so I can move on to the factoring. And since a equals 1, I know that my first term in both binomials is going to be an x. All right, so what I need to do is I need to find out what number go in those 2 spots, right? Plus or minus some kind of number, plus or minus some kind of number. Right? I need to find those numbers. And the way we do that is we know that we need 2 numbers that are going to multiply to this number and add to this number. And so they're always going to multiply to that constant c and add to that middle term, that middle coefficient b. So I need 2 numbers that multiply to 6 and add to 5. Right? Now, maybe you see this, maybe you don't. We literally kind of just looked at it down below, but that's okay. I think sometimes people get a little too confident on this and they just throw numbers in there. What I like to do, and what I showed when I was finding GCFs, is a systematic approach. Right? I like to have a surefire way of saying, hey, I'm always going to find my answer by doing this. Right? And especially this gets more helpful when the numbers are a lot more difficult than 5 and 6. Right? So what I do is I make a little table. Right? So here I have a table. And the first thing I do is I look at the number I'm multiplying to. And I'm multiplying to a 6, more specifically a positive 6. The only way to multiply to a positive number when you have 2 numbers is if they're both positive or both negative. And so I know the 2 numbers that I'm going to put down here are going to have the same sign, either both positives or both negatives. And then I look at that term that we're going to add to. And the only way to have two numbers be the same sign and have them add to a positive is if they're both positive. So I mark that on my table. Each side of the table is going to be a number. They're both going to be positive. Right? And then I have to add to 5 and multiply to 6. Now, let's say I didn't know what the signs are. There's infinitely many numbers that add to 5, but there's only a few numbers that multiply to 6. So I always start with the multiplication. And I always start with 1. I know 1 is going to multiply to 6. So I have 1 and 6. Right? I know they're both positive because I've labeled my table, so I'm going to go ahead and compute that or add them together. 1 plus 6 is 7. Now, they multiply to 6, but they add to 7. So that's not going to be what I want. So I'm going to go to the next one. Does 2 multiply to 6? Yeah, 2 does multiply to 6. 2 times 3 is 6. And then I know that they're both positive. Plus 2 plus 3 gives me plus 5. So those are the two numbers that I'm going to want in my parentheses. Okay? That's the way I always do this. Now, that table might be able to be done in my head with easier numbers like 5 and 6, but I like to make sure that I get it right, so sometimes I'll write it out even if not. Now, when you're writing the two factors, x plus 2 and x plus 3, it doesn't matter what order you write them in because multiplication is commutative. So if you put them that way or if you put them this way, it's the same thing. So don't worry about that too much. All right, so let's do the next one. I'll come down here. All right, so again, I want to make a little table. I know I'm going to multiply to a positive 6. And we're going to multiply to this one and add to a negative 5. So again, we're multiplying to a positive number, so they're both going to be the same sign. But since we're adding to a negative, I know they're both going to be negative. And again, I like to put in my parentheses because that's going to be the form of my answer. And since a equals 1, I know the first term is x. Right? So I get these things out of the way. And then I can just go ahead and try to find my numbers. 1 times 6 is 6, and they're both negative. But negative 1 plus negative 6 is negative 7. So that's not going to be what I want. And then negative 2 multiplies to 6. Negative 2 times negative 3. Negative 2 minus negative 3 is minus 5. Oh, look, I found my two numbers, negative 2 and negative 3. So they're going to go in, and my answer would be right here. All right, so let's take a look. I use these numbers on purpose because these quadratics usually I can trick people with. Right, you're thinking, oh, all right, we've done this. I know it's going to be 2 and 3, right, something like this. And that's not the case here. Right, so that's why you kind of have to take your time and be careful and really pay attention to the signs on the numbers that you're multiplying and adding to. Right, here we're going to multiply to a negative 6 and add to a positive 5. Right, now it's different because we're multiplying to a negative number. The only way to multiply two numbers to be negative is if one is positive and one is negative. Right, so I know I'm going to have a positive and a negative number. So I can label the table as such. Now, it doesn't matter which one you do what. You could do the plus on the left, the minus on the right. Now, I have to look at what I'm adding to. So I have to think to myself, okay, I'm going to be adding a positive and a negative number. The only way that a positive and a negative number add to be a positive number in the end is if the bigger number is positive. So I like to label that here. When I start writing my factors of 6, or the things that multiply to 6, I need to make sure the bigger number's on the right, or where the plus sign is. And again, you could do that differently. Maybe you put the minus on the right side, so then your big number is going to be with the plus on the left. Right? That's up to you. Just make sure that the bigger number is associated with the sign on whatever you're adding to when multiplying to a negative number. All right, so again, I'm going to start with 1. Now again, the smaller number needs to be on the right. So negative 1 on the right. 1 times a positive 6 makes a negative 6. Negative 6 plus negative 1 is a positive 5. So here you go. I found my two numbers, x plus 6 and x minus 1. And again, the order of this doesn't matter. I could have also put the minus 1 first. Right? And now I have my answer. That's the factored form of this quadratic. All right, so let's take a look at the last one. All right, so same thing. I'm going to be adding to a negative 5, multiplying to a negative 6. I know I'm going to have two binomials as an answer. They're going to start with x because a equals 1. And I'm going to have my table. I'm multiplying to a negative, so I'm going to have a positive and a negative. And I'm adding to a negative, so I know the bigger number is going to be negative in this case. And so I make a little note to myself. And I'm going to do the same thing. Find the factors of 6. I start with 1 because that's always going to multiply to whatever we're multiplying to. So a positive 1 times a negative 6, and add those together, and I get a negative 5. And oh, look, that's what I was looking for. That's what I wanted to add to. So here's my two factors, or two numbers that finish this, plus 1 and negative 6. And here I have that. Now, if you wanted to check any of these, you could FOIL these back together, distributively multiply, and make sure you get back to the original quadratic. Check out the next video for more difficult examples.